Hey everyone, this is lesson 4, solving equations by factoring. We did a little bit of this in class today as far as just taking a factor, setting it equal to 0, and getting that x value that would make your equation 0. Remember always that when we're finding those solutions, we're finding where that function would cross the x-axis. And so we're constantly looking for those zeros. Of your function, and that will continue as we move up into higher polynomials, and then eventually when we start graphing these, it'll kind of come full circle. But just a quick review of what we talked about in class today. If a times b is equal to 0, then we know that either a is equal to 0 or b equals 0. Not to say that both couldn't, but remember with an or statement, as long as one of them is true, then it makes the entire thing true. So that being said, you're going to always make sure that your equation is equal to 0, because then we can use that zero product property to identify what are those values of x or y or whatever our variable happens to be. Then we can factor, and then again we can use that rule. We have factors that are being multiplied by each other, so we know that if any of them are 0, then the whole thing goes to 0. So for example, if you have 2 times 3 times 0, right, just that single 0 in there makes this entire thing go to 0. So we're going to look for what values for x, or what values for our variable, will make each individual factor equal to 0. So then our last step here is to set each factor equal to 0. So again, we did a little bit of this in class today, so I'm not going to spend too much time, so feel free to pause the video or slow down and back up, whatever you need to do. Factoring part, I'm going to go fairly quickly. So your first step is to get your equation equal to 0, right? Then we factor, so this has a GCF, so we take that out. And then we factor again our trinomial into the product of two binomials. So we have y and y. 20 is 2 and 10, or 4 and 5. Well, 4, 5 will give us the 9. So plus 4 plus 5, this is equal to 0. So again, keeping this in mind up here, that we want any of our factors to be 0, and that makes this entire thing go to 0. So we have 3 factors here. 1, 2, 3. So y equals 0. Y plus 4 can equal 0. Or y plus 5 can equal 0. So we want what y values would make any of those equal 0. Well, y equals 0 doesn't solve, so that's just 0. Here it would be negative 4, and here it would be negative 5. So that is your solution set for this function. All right, so if you went into like Desmos or your graphing calculator and you graphed this function here, it would cross the axis, the x-axis, at 0, negative 4, and negative 5. Okay. Try to make it easy on yourself when you're solving. There's no reason to factor this one just like it is. I have a lead coefficient of negative, which makes it hard, and all of these have at least a 2 in common. So we're going to divide everything by negative 2. And I don't have to pull it to the front like I did up here with this y, because I have an equal sign. And so I'm technically dividing both sides of my equal sign by negative 2, which just goes to 0. So this becomes 24b squared minus, make sure you change your signs, 14b minus 3 equals 0. So that's going to break into two binomials here. We're going to do 6b plus 1. 6 times 4 is 24, so 4b minus 3. Quick check here. 3 times 6 is negative 18, and here is our positive 4, so that's negative 14. So that works out there. So that equals 0. So then you just take each of those. 4b minus 3 equals 0, and 6b plus 1 equals 0. So b equals 3/4, right? Add 3, divide by 4, and b equals negative 1/6. So either of those would make it 0. And when we're talking about x-intercepts, we would use the word and there. This one's a little bit different. We can't just say x plus 2 is equal to 20. X plus 3 equals 20. Remember, the whole point of this is to find your zeros. So this is actually multiple steps here in that we need to get this equal to 0. Well, if I just subtract 20 over, that's still not really doing anything for me, right? Because I now have subtraction, I can't say x plus 3 is equal to 0. That doesn't work there. If that goes to 0 right now, the whole thing will just go to negative 20. That would be false. So you actually do go ahead and multiply these out. So you have x squared, there's 2 plus 3 is 5x plus 6 minus 20 equals 0. So now I have x squared plus 5x minus 14 equals 0. So it kind of becomes a little bit more involved of a process here because we had to multiply, and now we actually have to refactor it in order to solve by factoring, which is your goal. So x and x, 14 is 7 and 2. We want a positive 5, so positive 7, negative 2 equals 0. And you'll get to the point, hopefully, where you can just recognize the fact that, well, there's no lead coefficients here. When I solve this, I'm just going to get x equals negative 7, x equals positive 2, right? It's just going to be the opposite of whatever's in there. You would add the 2 over or subtract the 7 over. So that might save you a little bit of time there, and that you don't have to physically write out x plus, I'm going to go ahead and write it out now, x plus 7 equals 0. You don't necessarily have to write that out to recognize what the answer would be. Same thing up here. I know I'm going to subtract 1 and then divide by 6. That should be mental math for you guys. Last one, factor by grouping here. Don't be dismayed by the fact that there's an n cubed. If we go back up here, we had a y cubed, and we had 1, 2, 3 answers. That's pretty typical, right? You can have up to as many answers as your highest exponent, right? We just had a squared here. We have 2 answers. We can't have any more than that. So this one, we're most likely going to have 3 answers. Sometimes one of them has a degree of 1 or 2, like you'll have an answer that occurs more than once, and that's fine also. So you may not have as many as you have your exponents. But we're just going to group here. So here's our first group. Here's our second. We're going to pull out a n squared. So n squared comes out. We're left with n minus 2. I'm going to take out a negative 1 because my lead coefficient is negative. I'm left with n minus 2. Well, n squared minus 1 is going to factor again. So let me write out real quick. N squared minus 1 and n minus 2 are my factors. You can break down n squared minus 1 again. But if you remember from your Algebra 2, you can also solve this. So we know that n squared minus 1 equals 0. Well, that means that n squared is equal to 1. You think about how can you get rid of a square root? Well, the opposite of a square root, or a square, excuse me, I'm telling you the answer. The opposite of a square is a square root. So we're square root both sides. But the trick with these, not really a trick, but the rule with these is that we're not just going to take the principal root. And the principal root is the one you would get in your calculator, right? We also have to know that there's another number that when we square it will turn out to be a positive 1. And that's negative 1. So this actually gives us the answer of plus or minus 1. So you get your 2 answers out of that, right? Your other option would have been to break this down even further in plus 1, n minus 1, and there's your negative 1 and your positive 1. So then we have n minus 2. So we have n equals negative 1, n equals 1, and n equals 2. Those are our 3 answers for this one. Okay. So whether you choose to factor it all the way out or just remember your rule with square roots that you have more than one possibility, either way is fine. Moving on. All right, the next type that you'll run into is absolute value. We've talked about absolute values before. Remember, every absolute value has 2 possible cases. You have your negative case and your positive case. And all that's doing is it's representing on a number line, you're either moving, in this case, 8 to the right, or you're moving 8 to the left, right, from a center point. Well, this represents that center point. So we have to figure out both our positive case and our negative case. So we do x squared minus 2x minus 16 is 8. But we'll also do x squared minus 2x minus 16 equals negative 8. Okay, same rules apply. We have to get this zeroed out, all right, get it set to 0. So x squared minus 2x minus 16, oops. Minus 16 minus 8 is minus 24. All right, so then we factor x and x. 24 is a lot of factor pairs for 24, right? But we want them 2 apart. So we have 4 and 6. That's going to be the 4 and 6 are only 2 apart, right? So minus 6 plus 4. So x equals 6 and x equals negative 4. So we get 2 answers over there. But we're also going to solve our negative case over here, which means similar steps, but see here we have to add 8. So we get negative 8. So you can see we're going to get different answers because our last number here is different. So this factors, multiplies to negative 8, adds to negative 2. Well, 4 and 2. So minus 4 plus 2. So x equals 4 and x equals negative 2. So your entire solution set, I'm just going to go ahead and put these in order, negative 4, negative 2, 4, and 6. For any of those 4 values. So if you plug any of those 4 values into your original equation, you will get 0. What happens if you have multiple variables? That's the next type you will see. You do want to make sure you learn how to do these types of problems for sure. Hint, hint, I guess. So again, we're going to do this by grouping. So you have your first group here and your second group here. This one, a y comes out, so we're left with y minus a. This one, a negative b comes out, so we're left with y minus a. Remember, your goal is always to get those to match. So I'm not going to get a numerical answer here, but I can still get my y's by themselves. So y equals b and a would be my solution set here. And that's totally fine, right? This kind of shows you the pattern, the breakdown of when you're factoring by grouping. A and B are often used to generalize numerical values, just so that you can break things down and see the pattern behind them, other than just using numbers and thinking you have to have those same numbers every single time. Same thing with a trinomial here. If you have 2 squares on opposite ends, right? When you break that down, you know that it has to be y and a. Y and a. There's obviously also going to be number values that we have to take into account. So we have our 9 and our 6. Well, 9 is a perfect square and 6 is double that root. So this is a perfect square trinomial. So this is plus 3 and plus 3. You don't have to know that to get there, though. So if I solve for y, when this happens, when I have y plus a value and then that same thing, I can write it as squared, right? Well, I'm only going to have one answer. So unlike number 5 up above where I had 4 answers, so I doubled my answers here, I'm cutting that in half. I have the same factor twice. Y is going to be equal to negative 3a. That's the only thing that will make this equation equal to 0. Okay. So anytime you have a perfect square trinomial, you're just going to have that single answer. The last thing I really want to dive into, and I've already gone longer than I wanted to with this video, but is looking at the application of this. It's one of those rare things. There's really not, you can look down here, we only have 2 application problems for this whole unit, because it's kind of a gateway into applications that are actually used, but without some higher level mathematics, we can't really dive too far into it. But quadratics have to do with the pull of gravity. So anything that involves the pull of gravity, you can put into some sort of quadratic form. So here we have a function, and I know I'm not reading this all the way down, but we have this function, negative 16t squared, and it's right here. This negative 16 is the pull of gravity in feet per second. The other numbers in here are going to represent heights. So like if you, or initial velocity and height. So we go up here, this 128 feet per second. That's how fast this nail is traveling out of this nail gun. Why no construction worker would ever fire their nail gun up like this. Just, I know that, you know that, it's fine. But anyways, the height that it's starting is 144 feet. So this initial height back here, or if you have a number being added to it, it's always an initial height. Sometimes somebody will be standing on the ground and they'll take that initial height as 0, even though technically, like if I was standing on the ground firing it up, the gun would be starting at around 5 foot something, right? So these aren't always 100% accurate, but they're going to get you fairly close to the actual value. It will often then ask, how long does it take for it to fall to the ground? Okay, well, it's not going to tell you the ground height is 0. This is just something you have to know. So we're taking this whole equation, we're just setting it equal to 0. So negative 16t squared plus 128t is equal to 144. And I might add on to this. Sorry about that. I might add on to this question here in a second. Another question that you'll see. Oh, I need to fix this. This is plus. Okay. A lot of the times, again, because of the level we're dealing with, these numbers will be divisible by 16 itself. So I'm just going to double check that here real quick. So 128 is, and 16 is. So I'm going to, all right, 144 is. So I'm going to divide everything by negative 16. And this is going to give me t squared minus 8t minus 9 equals 0. So t minus 9 and t plus 1. Now, because we're talking about time, how long does it take, we only really need the answer that's going to give us a positive value. We're not going to measure time in negative seconds. So that gives us negative 1. So t equals 9 seconds. So 9 seconds for it to reach the ground. Another question that might be asked of you on this type of scenario is, how high is the nail after, I don't know, 3 seconds? Okay, and that's just an evaluation problem. You are literally just plugging in 3 for t. So negative 16 times 3 squared plus 128 times 3 plus 144. And that will give you your answer. I'm going to pause. So you type that in your calculator. I got 384 feet after 3 seconds, right? And you have to think about the shape of this nail. It's coming from this roof line and coming up and then coming down and then hitting the ground. So there's even a spot here where I could see, okay, how long did it take for it to come back to 144 feet? And I could have set h equal to 144, subtracted that over and solved that, and then that would have given me the time for it to come back to it. So there's lots of different questions that could be asked out of this scenario. And the last one is, we've talked a lot about perimeter, but we can also look at area, because area is a quadratic. It's length times width, so that's where we can get that x squared here. So a total of 34 feet of lumber was used around the perimeter of a gate. If a diagonal brace is 13 feet, what are the length and width of the gate? So this is still perimeter, okay, but it's dealing with a triangle. So here's my whole gate, but here's my diagonal brace going down the gate. So I know that this diagonal is 13. If you remember your Pythagorean triples, then you could come up with those fairly quickly. Most people don't have those memorized though. So I'm just going to call the total lumber around the gate is 34. So I know a squared plus b squared. Okay, sorry, I had to deal with my puppy dogs. So I'm going to just start this problem back over again because honestly I can't remember where I left off. So again, we have this gate and we know that the perimeter of the gate is 34 feet. But because we're given this diagonal length here, we know that this is 13. We're really just going to deal with this rectangle. So recall from geometry, or this triangle, excuse me. Recall from geometry that when you're dealing with a diagonal in a right triangle, then you're also going to deal with Pythagorean theorem. So a squared plus b squared is equal to c squared. This is helpful to us because we have, right here, we have our squared. So this is a quadratic, right? So we just need to identify then how we can express our length and our width. That's what we're finding. What are the length and the width? We don't know, right? The only thing that we know is that the entire perimeter is 34W, or 34, excuse me. So all the way around is 34. Well, we do know that perimeter is 2L plus 2W. Okay, so 34 equals 2L plus 2W. We divide everything by 2, 17 will equal L plus W. All right, so divide by 2. And so I can choose either L or W, it doesn't matter, to subtract over. So let's subtract W. And now we know that 17 minus W is equal to L. Okay, so 17 minus W equals L. So if this represents my length, I can now write it as 17 minus W, and then just let W be W. So then I have all of the parts to my triangle, and I can just plug those in to my Pythagorean theorem. So here's my A, here's my B, here's my C. So remember to put everything in parentheses. Okay, so I'm going to have W squared, don't need parentheses on that, plus, but here I need 17 minus W squared equals 13 squared. Okay. All right, so then I can just expand and simplify. I may not have given myself enough room here for this problem. Apologize for that. So here we have w squared plus, this is a perfect square trinomial, so I'm just going to kind of do this here using the pattern. So remember, use square the first term, so 289. You take the product of the two terms times 2, so that's minus 34w, and then you square the final term, so plus w squared equals 169. Alright, well, this is a quadratic, so I need it to set equal to 0. So I'm going to combine my steps here. I'm going to get this set to 0 by subtracting 189 and combining like terms at the same time. So let me switch colors again here. Have now 2w squared, because I have w squared, minus 34w plus 289 minus 169 is 120 equals 0. Well, I could use my method of factoring here where a does not equal 1, but everything here is divisible by 2, so I'm going to do that. Now I have w squared minus 17w plus 60 equals 0. And my last couple steps here, I'm going to factor this, so I have w and w. I should have used L, but it does not look like a W. Let's see, multiplies to 60, adds to 17. I have 6 and 10, that's too close. Adds to negative 17, sorry. So I need them to be the same sign. So that's negative 16, so that's really close. So I'm going to go 5, because that's the next to 6, and 5 goes into 60. 12 times, so there's negative 17. So minus 5 minus 12 equals 0. This time they both come out positive, and that's because I'm looking for my dimensions, so I have two sides. So w equals 5, and w equals 12. So it doesn't matter which one you let be w, because if you look over here, if w is 5, then 17 minus 5 is 12. If w is 12, then 17 minus 12 is 5. So those are the dimensions, the length and the width of your gate. So it's a 5 by 12 foot. That is a really bad F. Would be your answer. All right. So give this your best shot on the assignment. We will have quite a bit of time in class to work on it tomorrow. So if you have questions, you can ask me then. Have a good night.